This is Flare Engine. Welcome. In this tutorial, we're going to implement AI pathfinding. We're going to create a grid map that will generate paths, and we will get the AI to follow these paths. It's actually very simple to do. We will use an AI finite state machine and 2 nodes to accomplish this. I already have the level set up to save time. I'm using Unity tile map. So, what this looks like is not important at all. I'm mainly concerned with functionality. So if you want to use a tile map, please refer to the Unity documentation, or you can simply create a series of box collider 2Ds with sprite renderers and arrange these blocks to create a basic level. The important part is that whatever colliders you're using, their layers are set to world, and whatever technique implemented to build your level, the platforms must align with the pathfinding grid. Okay, let's begin. I have the player, a camera, and an ogre. The ogre sprites are actually not included in the project as of now, but I provided a link in the description if you want to follow along with these sprites. Again, the visuals are not important right now. You can simply use a simple square texture and everything will work just fine for learning purposes. The ogre has a box collider 2D and a sprite engine. I will quickly show you the setup. The first step is to create a pathfinding grid. We create an empty game object, add AI finite state machine, we go into territory and add pathfinding. We modify the grid's position and size in the game world. This territory will determine where paths can be created. In general, the size should be reasonable. If you want to make it really big, it might slow down the editor, and it will cost more to use the AI pathfinding algorithm, so always test for performance. Okay, the main thing to be aware of is the jump distance. This is the jumping distance the AI can perform while jumping to platforms. It's really important. It determines where the AI can travel to. So when designing a level, keep this in mind, but of course, it's always possible to change these values. This is the size of each cell in the grid. We make sure Show Paths is enabled to display all the nodes in the scene once created. We give it a name. Now, we click the Create button, and we see that nothing was created. We must always specify the layer the colliders exist on. We set the layer to world, and also make sure the colliders you are using are set to this layer. We click Create, but nothing worked again. If you are using box collider 2Ds, this should have worked. But there is a peculiar edge case if you are using tile maps. We go into tile map, typically, your tile map should have a composite collider 2D to group your colliders. We must set geometry type to polygons. This will enable the raycast used by the pathfinding tool to detect the inside of the colliders. You will notice the changes in the scene. We try this one more time, and we see the nodes have been finally created. Enable gizmos to make sure the nodes are visible. If you are using tile map, we go back and you can revert to the original settings if you wish. Okay, we're halfway there already. There are 3 main nodes you have to be aware of. The green diamonds represent areas where the AI can walk. The blue diamonds represent jumping paths. If 2 platforms are connected by these, it means the AI can jump to and from them. The red diamonds represent locations where the platform is too high up for the AI to jump to, but the AI still has the option of falling down from these locations. Okay, and before we forget, we set the AI type to no collision checks. Typically, you don't want to recreate a pathfinding grid for every individual AI that will use it. One is good enough. So we leave the pathfinding territory on its own game object. Next, we go to the Ogre and we make sure the width of the box collider 2D is less than the cell size. I set it to 0.75. We go to the finite state machine and create two targets, player and target pathfinding. We name them. Target pathfinding will be in charge of following the generated paths. We set the reference to the pathfinding grid, which is in charge of generating the paths, and we leave the default speeds for now. Now we create the follow state, and we add pathfinder. We set pathfinding to target pathfinding, and the target we want to follow is a player. When the target changes its position by the reset distance, the AI will ask to get a new path to the target. We leave it at 1. Now we go into play mode. The AI can't use the ladder yet because we haven't set it up, but it should follow the player. Okay, everything seems to be working now. Let's go ahead and set up the bridges and ladders now. We create a couple of game objects, and add the bridge components, and place them in the scene. We set their sprites, and create them. Hopefully they're intuitive to understand, so just follow with me as I configure them. Now, we enable use bridges on both the player and the Ogre. We go back into Pathfinding Grid and set up the nodes for ladder, bridge, and ceilings. We must insert these manually. To do this, we enable the extra following ability we want to include. So we enable ladders, go into the scene, and we click on the node we want to act as a ladder. Clicking the same node again will undo the node. We now disable add ladders, and if you are using tile map, set geometry type to polygons again. Recreate the path to accept the new changes and go into play mode. Okay, it worked. Now we do the same with ceilings and bridges. With bridges, we enable the nodes all around the bridge since the bridge can change its Y position. We disable and recreate the paths. Now we go into play mode. Okay, so right there I noticed some glitchy behavior by the AI, and it's because the editor is making the game run slow. If you disable gizmos, everything will run just fine, but I'll see if I can smooth this out more in the future. Okay, we exit play mode now. One thing I want to note is that the ladders will not work with a player because these are AI ladders, but you can easily configure a ladder component onto these if you want, but to keep it short, I won't do that. Let's create more ogres now. We go into the ogre finite state machine and create units. This is basically duplicating the game objects by the specified number. However, the benefit is that every time you make a change to the main unit and repress this button, all the units will get their code updated so they all share the same code. We create them and reposition them in the scene. I'm going to maximize on play so we can test this without the editor slowing us down. You will immediately notice one thing, however, the units overlap. This is undesirable behavior. To fix this, we go to the main unit, go to target pathfinding and disable ignore units. What this will do is that all the AI using this pathfinding grid will not block each other if they're moving along the same line. We recreate the units and go into play mode to see the changes. Now we can see the AI units grouping together in a line, not overlapping. Okay, great. We exit play mode. You can also feel free to change the follow speeds. You can also pause the AI after it jumps so it doesn't continue to follow immediately. This will make it feel more natural. Okay, and finally, we're going to add a simple attack state, and then we're done. I added a very basic sprite for the attack animation, nothing too creative. Here's the setup. We add the attack state and signal. We use a slide node to attack with these settings, then exit out after half a second with a clock. Okay, and now? Most of the time when you want to exit a state that has a Pathfinder node, only exit out using the success on field. This will ensure the AI is not in an awkward state before leaving the path. We will move to the attack state when the AI is in a stable position, and the target is within this distance. We enable damage and recreate the units. Okay guys, that's it for this tutorial. Thanks for watching and see you in the next one.